Hello everyone, I am J. Aditya Rao and this is my team which includes G. Shiva, A. Dwaraknath Reddy and K. Sai Madhav, and this is our EMERTXE Embedded System Internship report. In this embedded internship we have done the project of microwave oven. Coming to the concepts which we have learned in the internship are C programming language, introduction to embedded system, memories and its types, components of embedded system, and microcontroller and microprocessor. Uh, Coming to the special project required board, which is PIC Genius board, and the microcontroller which is used in this board is PIC16F877A, and communication protocols, and the project requirements and execution, and then resume building. The goals of internship include the embedded systems and its applications and their significance, and to know the real world requirement on embedded system, to learn about the C programming language, uh, and to learn about microcontroller and its peripherals, also to learn how to write embedded C programming, and to gain knowledge about how peripherals and protocols are interfaced in an embedded system, and coming to the micro oven project requirements and its implementation. Coming to the C programming language, in C programming language we first learned about the basics introduction, about the C applications and C programming syntax. Then we also learned about the types of errors in C programming language. Then coming to the basic programming tools, or the code, where we use the conditional constructors such as if else and if else if and nested if, uh, which are used for decision making, and similarly switch case. And coming for the loops, we use while loop, for loop and do while loop. Then we also learned about the operators and the different types of operators in C programming language. Also for the conditional loops we also use the conditional statements, such as break, continue and jump to. These three statements are used to exit from the loop at different instances as required by the code. Then we also learnt about the arrays, their declaration and function calling. Then we learnt about the pointers, uh, different types of pointers, and pointers, pitfalls and segmentation faults. Then we learnt about the strings, storage classes and preprocessors and functions and macro. Then we also learnt about the memories. There are different types of memories such as RAM, ROM and flash. Even in RAM we have SRAM and DRAM, which is static RAM and dynamic RAM. And in ROM we have EPROM and double EPROM, which is electrically programmable ROM and electrically erasable programmable ROM. And in flash memory we have NOR flash and NAND flash. We have learnt about them in this internship. Coming to the components of the embedded system, in the embedded system we basically use the DAC, which is digital to analog converter, and ADC, which is analog to digital converters. In DAC we use ADC when we are taking information from the signals and giving them to the microcontrollers, and DAC is used to interface between the microcontroller and actuators. Then the other components are memory, and next the human interface, which is nothing but the LCD or LED or keypad, then ASIC, then sensors, then diagnostic ports, and the main brain of the embedded system, which is microcontroller and microprocessor. Coming to the microcontroller, in this project we have used the PIC Genius board, which consists of the PIC16F877A microcontroller. This microcontroller has 4 ports. We use port B and D for the LEDs especially. Let us see in detail about them. See here we have, as I have told you, we have 5 ports. We use port A for push button and potentiometers and relays, and also for RTC also, and port B is used for LEDs and push buttons and keyboard. Similarly, port D is also used for keyboards, 7 segment multiplexer display and LEDs, and PS2 and LCD 16 cross 2. Port E is also used for temperature sensor and LCD also. Port C is used for fan tachometer, heater, serial, I2C, double EEPROM, RTC, relay and buzzer. These are the usages of these different ports in this PIC microcontroller. And we have the host which we use for this project is MPLab XIDE, and the simulator which we used is PICSimLab. Coming to the different peripherals which we used in this project are switches, timers, CLCD, buzzer and fan and LEDs. We interfaced LEDs, digital keypad, interrupts, timers, clock IO, SSDs, CLCD, matrix keypad and analog inputs. Coming to the interfacing of switches, we use pull-up circuit and pull-down circuit. Edge and level triggering can be used for interfacing these switches. These switches are arranged in matrix so that it is called as matrix keypad, each switch having unique task to perform. So as we have edge triggering and level triggering, we can use this edge and level triggering based on the applications, when the operation should happen when we press the button. Coming to the LEDs, we interface the LEDs using the port B and port D of the microcontroller. When these two ports are using these two ports, we activated the LEDs, and using the TRISP LEDs are declared as input or output. This TRISP is the keyword in the code which we use. And next, these all ports are registers. These all ports and registers are 8-bit. Coming to the interrupts, there are different types of interrupts that they can be mainly classified as two types of interrupts, such as maskable and non-maskable. And these interrupts arrive in an embedded system, and when these interrupts are arise, the microcontroller goes into a state called ISR, which is interrupt service routine. Then comes, after completing the interrupt service routine, it comes back to the instruction which is executed just now. Next, GIE means global interrupt enable. Next, we also learnt about the timers, the resolution of the timers and the register width. We also know tick is the up count or down cut. Next, about the quantum also we have learned, that is system clock settings, and whereas scaling which means pre or post. And coming to the modes in the timers, which is counter and pulse width modulation PWM or pulse generator, or PWR PP measurement, etc. From this slide, my friend Sai Madhav will continue.
Thank you, Mr. Aditya. And the next component after the interrupts and timers was CLCD, which is defined as character liquid crystal display. A character LCD or CLCD is one of the most common output devices in embedded system. It displays ASCII characters and comes in formats like 16 cross 2 and 16 cross 4. It was mean that 16 characters per lines across multiple lines. CLCDs can operate in either 8-bit or 4-bit communication modes depending on the design requirements which we need. They are widely used because they provide a simple and effective way to communicate information to the user, such as status of the message or numerical data. In this, To understand these peripherals better, we implement small programs. For example, toggling an LED when a switch is pressed or blinking an LED every second using timers. Another program displays messages like hi or hello on CLCD. We can also show numbers and words which demonstrates how embedded C program interacts with hardware. These exercises build the foundation for larger objects by teaching us how to combine inputs and output and the logic of these peripherals. And the next one was project requirements. Our main project is the simulation of a microwave oven using embedded software. The user interacts with the system through a matrix keypad while the output is displayed on the CLCD. The system must control cooking modes, time, temperature or fan or heat operations. This project brings together all concepts we have learned previously, that is programming, interfacing and peripheral controls into a single practical application. And the requirements are first one the power on. First one, as we know, that the power on the screen. When the system is powered on, the CLCD displays a welcome or power on message. This simple step reassures that the user that the system is reassures the user that the system is ready. It's the first interaction point and sets the stage for selecting cooking modes. And the requirement two was cooking mode selection. Next the user selects the cooking mode using a matrix keypad. The available options are macro mode, grill mode, convection mode and the quick to start mode. For example, in this, as we know that input was the matrix keypad which presents switch 1 to switch 4. For example, switch 1 for macro, switch 2 for grill, switch 3 for convection and switch 4 for quick start. Once selected, the chosen mode is displayed on the CLCD, making the interface clear and user friendly. And the third requirement was macro mode. In a macro mode, the user sets the cooking time using the keypad. The display shows the power level and the entered time in minutes and seconds. The star key clears the time while the hash key starts the cooking. During the operation, the CLCD shows the remaining time. Controls like start, pause and stop allow the user to manage the process easily. This mode demonstrates how timers and keypads input work together. And the fourth requirement was grill mode. In this grill mode, it mostly focuses on the grilling operation. The user sets the cooking time, clears it with the star key and starts with the hash key. During cooking, the same control keys like resume and pause and stop are available. This mode highlights how embedded system can adapt the same hardware to different functionalities by changing the software logic. And the requirement 5 was convection mode. In this convection mode, inputs are keypad or timer. Functions in this convection mode are setting the temperature, preheating starts automatically. After preheating, user sets cooking time. In this requirement 5, we control by clear operation by using the star key and the start operation by using the hash key, and the switch 4 for resume and switch 5 for pause and switch 6 for stop. And the last requirement was start, that is quick to start. It is the requirement 6. In this requirement, inputs was switch 4 and the functionality of this requirement 6 starts the microwave for default for 30 seconds. Each switch 4 press adds plus 30 seconds. It controls switch 4 for resume. In this requirement 6, the three switches are used for controlling the operations, that is switch 4 for resume or add time, switch 5 for pause and switch 6 for stop and return to cooking mode screen. Thank you, and the next coding part will be discussed by the Mr. Dwarak.
Presentation. Now coming to the coding part of the project. Here the first 4 lines of the code includes the header files. The first header file is for the PIC microcontroller. The second one is used for the character LCD. Third one is used for the macros like fan and etc. And the fourth one is used for the matrix keypad. And the second part of the code is for declaring the variables like minutes, seconds, temperature, flags and heat etc. And the
Next part is defining the power screen of the project, and here the bar and line, this line is used to load the loading effect, and after loading here comes the powering on message, and below that the microwave on message would be shown. And after that again we will be having a loading effect of the bar, and after that we will get a menu of 4 options: micro, grill, convention and start, in the respective lines 1, 2, 3 and 4. And after the menu there will be our option to set the timer. To set the timer we take inputs as character key and the reset flag. The character key input is given from the matrix keyboard, and the reset flag is used to reset the timer. So whenever the reset flag is 1, the timer is automatically set to 0. All the seconds, minutes and everything is set to the 0. And if the reset flag is not 1, the display shows the message as set the timer in the formats of minutes and seconds. And after setting the time, if you should be entering start to clear all the time, and hash to save the time and start the microwave. So coming to the next part, here if the key entered, the first 2 characters of the entered keys would be treated as seconds, and the next 2 will be treated as minutes. So if the keys, if the character entered is start, the all the seconds and minutes would be reset to 0. And if the character entered is ash, the screen is cleared and the fan would be turned on, and also the timer. And here the screen flag is equal to display time. That means the screen is changed to displaying the time. And here this is a blinking effect. This effect is used to blink the timer in the LCD. And coming to this part of the code, here if the reset flag is equal to 1, the temperature, key and key count, everything is set to 0. And for 5 seconds the display is set to the blinking effect again. And here comes the setting the temperature, and the display shows set temperature, temp and start to clear and hash to enter, same as how we set the timer. So in the similar manner we would be setting the temperature, and if the entered character is start, everything is reset, and if the entered character is hash, the microwave would start cooking. So when the microwave starts cooking, the timer 2 is on, and here the preheating message is displayed. And along with the preheating message, the timer is also being displayed here, and this code is used for the blinking effect. And once the time is up and the minutes and the seconds variable is equal to 0, the screen is cleared and the timer and the fan are turned off, and the message displayed in the character LCD display is time up and enjoy your meal, and the screen flag is turned to menu flag. That means the screen would be.
Thank you, Dwarak. Coming to the simulation part, I am using a PIC Genius board in PICSIM lab of microcontroller PIC 16F877A with a clock frequency of 64 MHz and a LCD display HD 44780 of 16x4. And coming to the simulation part, we are using 4 modes: micro, grill, convection and start. Coming to the first mode, micro. Here we will be setting the timer. Let us set it to 12 seconds, and hash is used for enter and star is used for clear. You can see that the timer is running. Coming to the second mode, grill. I will be setting timer for 30 seconds now. Hash for enter. You can pause using 5 and resume using 4. 6 for stop. Coming to the third mode, convection. Here we can set the temperature in degrees Celsius, like for 50 degrees Celsius. Hash for enter. It will be taking 60 seconds for preheating. After preheating, we have to set timer for oven. I will be setting 2 minutes of time. Five for pause, 4 for resume, and 6 is used for stop. Four is used for a default timer of 30 seconds. 5 is used for pausing the timer. 4 is used to resume. As I have used a 64 MHz clock frequency, the timer is moving so fast. We can change the clock frequency to 32 MHz. Now you can see the timer is slow. Thank you.